discussing common logs. For those of you who don't know what a common logarithm is, or even what a logarithm is, simply put, a logarithm asks, what exponent must you raise a base number to get the answer? Verbally, that may seem difficult to understand, so let's write one out. To save face, we'll use a common log. Log base 10, a common log, of 1,000 equals x. Okay, some people look at a log and automatically will understand it. But for most people, it's just easier to change it to its exponential form. So looking at our definition, which is what power or exponent do we need to raise a base number to so that we get our answer. Hold on. Okay. So, now I'll show you the parts of a logarithm. This is the answer. This is the exponent. And here we have our base. In a logarithm, it's easy to remember the order through a simple mnemonic. I personally use large brats are expensive every day, meaning logarithm base answer equals exponent. And that way I can memorize which way a logarithm is set up. So, log base answer equals exponent. So looking at log of 1,000 with the base of 10 equals x, we ask what exponent must we raise 10 to get 1,000? Over here I have how to change a logarithm to an exponent. a logarithm, as we have here, log base answer equals exponent. To change it to an exponent, we have base to the power of the exponent, x, equals the answer 1000. So, base 10 to x to the power of x equals 1000. There are a few fairly simple methods to this, including the count by zeros method, which can only be used on common logs that are multiples of 10, or the divide by logarithms method. The count by zeros method is just that. Basically, you look at your answer, 1000, count the amount of zeros that are either in front of it, or in front of the decimal or behind the decimal, and that number will give you your exponential value. 1, 2, 3 zeros, so we know that x equals 3. You check that in your calculator by substituting 3 for x in the equation, and you will get 1000. So, what happens if we take the log, let's change the color, the log of 1000 with the base of 10. Well, we said that each zero behind or after the decimal will give us our x value. Here we have 1, 2 zeros. So does that mean that x equals 2? No. X does not equal 2. With this method, we must see how, with this method, we must see where the zeros sit corresponding to the decimal. If the zeros sit behind the decimal, then our x value will be negative. If they sit in front of the decimal, like so, our x value will be positive. So here we have 2 zeros behind the decimal, meaning that x equals negative 2. The best way to remember this method is by thinking of it as a reverse number line. If the zeros and whole number are before the decimal, then the exponent will be positive. Just like on a number line. This is your number, or your answer. A for answer. 1, 2, 3. All positive because they're before the decimal. After the decimal, you'll have your negative numbers. -1 and negative. Now on to method number 2. While most common logs can be manually solved, at times you are given a common log you must use your calculator for. For instance, the log of 4 equals x. We all know that 10 does not simply multiply into 4. So what do we do? First, we'll turn the log of 4 into its exponential form. You should get 10 to the x power equals 4. Now, we're going to have to turn 10 to the x equals 4 into logs on both sides. That way we can set the problem up to find x. Therefore, we get the log of 10 to the x power equals log of 4. But since we must find x, we have to bring the x in front of log of 10 so that we can solve for x. Down from an exponent to a multiplier of log of 10 equals log of 4. Okay, so now based on basic algebra skills, we know that to isolate a variable here, we must do the inverse operation that this variable comes in contact with. Here, it's multiplication. So, we know that we must divide log of 10 by both sides. So let's do that. What you should have gotten as your new equation is the log of 4 over the log of 10. Plugging that directly into your calculator, you should get x equals 0.60206 hundred thousandths. So now we have to check to see if our answer is correct. So what we'll do is plug our new value of x into 10 to the power of x equals 4. Substituting x for 0.60206 hundred thousandths into the equation 10 to the x power equals 4, you should get 10 to the power of 0.60206 hundred thousandths. Does it equal 4? So to find that, you'll just plug this part of the equation into your calculator and see if it gives you 4. So do that now. If you did get 4, then you did the equation correctly. Congratulations. This means that you're ready to do a couple of them on your own. Try these few on your own, and I'll post the answers in the description below. Thank you.